Welcome to aminacademy.com. In fluid mechanics, let us do some example problem regarding total pressure and center of pressure. A metallic tank having 2 meter wide contains water up to a height of 0.5 meter above the base. Above the base, an immiscible, not mixing with water, of specific gravity of 0.8 is filled on the top of water up to 1 meter height. Calculate total pressure on one side of the tank, the position of center of pressure for one side of the tank. Here, this one is liquid. SPGR, specific gravity, is 0.8. Here, this is water. Now, the depth of water is 0.5 meter and depth of liquid is 1 meter given. Now, the given points. Now, depth of water. Depth of water equals 0.5 meter. Depth of liquid 1.0 meter. SPGR, specific gravity of liquid, equal 0.8. Therefore, density of liquid 0.8 into 1800 kg per meter cube. Density of water 1000 kg per meter cube. Now, first one, total pressure on the side of the tank we will calculate. Total pressure on one side of the tank. For this we have to draw pressure diagram as follows. Now the pressure at A, suppose the position A is here. Here position D and E. Position BA here we can write. Now position B here we can write here. Suppose you put C. Position C. Now here intensity of top of the first intensity of pressure at on top, pressure on top. Suppose write PA must be 0. Here there is no pressure due to liquid or water in this surface. So the point A, we can put here. This is a point A, and intensity of pressure at point D, intensity of point pressure at D will calculate because of the liquid that is here. Intensity of pressure on D, or we can put E both point. Here we will put PD equal rho 1 GH1 is 800 because its liquid density is 800. 9.81 into H1 is 1 meter. So which gives 7848 Newton per meter square. So we have to put some first we'll draw the vertical line here. Force diagram for vertical line. Then here, and also we'll put about the intensity of pressure on intensity of pressure on base BC. Here intensity of pressure on C, we can put some other letter here. Base BC is PB, you can write pressure PB is addition of pressure due to liquid and due to water. So we have to do PB equal rho GH1 rho 2 GH2. We'll calculate here. Already rho GH1 is 7848 plus water 4000 density 9.81, H2 is 0.5, which is equal 7848 plus 4909 total equal 12753 Newton per meter square. So we have to get the basis for total basis 12,753, and out of that we have to split these two bases. Suppose here we will draw a force diagram, pressure diagram. Take this much is the pressure PA, that is 7848. For some scale we have to do 48. Then this is 4905. And here we have to put this one is 0.5, this is 1.0. Now then draw a base for water here and join this for then this for now we have drawn force diagram for set and scale. Now we'll put force CG of this here. This is a three part of the things. One triangle, here triangle, one rectangle. Therefore force F1 will act 2/3 of the base here, that is put CG here. Let it be this one F1. For rectangle, the middle of this one is F2, and for triangle another 2/3. This is the force is acting like this F3, 0.5 here, the force F3. So we have to calculate each forces here, F1, F2, F3 from the diagram. F1 equal to area of triangle. We can put the triangle name now, ADE, and point B here, and C. ADE, area of triangle ADE, equal area of triangle ADE equal half into AD into DE width of the tank, width of tank here, which is equal half into AD is 7848. This is 7848 for DE because this is 7848, and 7848 and height is 1. First AD is 1 into 7848 into width is 2, which gives 7848 Newton. Then F2 is the area of the rectangle, area of rectangle is half, no, area of rectangle DBFE, equal base into height. Base is height is 0.5 and base is 7848 into width of the tank is 2. So we have 7848 Newton. F3 is area of triangle, this, suppose to name it F here, DFC area of triangle DFC equal half into EF plus FC equal half. Zero point 0.5, height is 0.5 and 4905 into width is 2. So gives 2452 2452.5 Newton. Therefore total pressure F equal F1, F2, F3. Then we'll do which is equal 7848 plus 7848 and third is triangle area is 2452.5 equal 18148 18148.5 Newton. Here the total pressure due to liquid of specific gravity 0.8 and water together given as F, that is called 18148.5 Newton total pressure. We can say it's a resultant pressure. Now after that we have to calculate center of pressure. Center of pressure. Here center of pressure we can calculate by taking moments h days F into total resultant force F into h days equal F1 into here this is a triangle, center of gravity is two-third from the here from A, two-third of AD because it's a triangle, two-third of AD plus F2 into AD plus rectangle is half of BD, means CG of this rectangle is this one AD, that is AD plus half of this half of dB. Half of dB, you can get it this one. Then F3 is another triangle with F3 is AD, the height from the apex, plus two-third of BD for the third triangle. We will put the values F total, then total pressure is 18148.5 into h days. The center of pressure, position of center of pressure equal F1 we have 7848 into two-third of 1 plus F2 we have same 7848 into AD is 1 plus half of BD 0.5 divided by 2 plus F3 into AD is 1 plus two-third of 0.5. Here we'll do this gives up to 7848 two-third of 1 . is 5232 plus here 0.5 divided by 2 is 0.25 plus 1 is 1.25 multiplied 7848 is 9810 9810 plus here 2 theta 0.5 plus 1 into F3 here 2452 here 2452.5 that is 2452.5 into 2 theta 0.5 into 1 plus 1 is 3270 which is give total of 18312 18312 Newton meter. Here this side is 18148.5 into H days. Therefore H days equal 18312 over 18148.5 which is approximately even 1.009 meter from top here, that is from the top center of pressure is nearly 1.0019 of this triangle. Here it comes near to the contact of liquid and contact surface of liquid and water, little below, that is 1.009 meter. We have done. Please subscribe our YouTube channel.